Good evening, everyone. I hope that you're all doing great. So I am Lina, a student at the Higher National School of Computer Science. And today we'll be having our fourth and last session of DevFest conferences that's held by BGDG Algiers and WTM community. So today we'll be having two amazing talks that will cover and involve many interesting and inspiring fields. So the first talk is titled Democratizing Big Data Analytics and ML with BigQuery that will be held by Dr. Nabil Hadj Ahmed. And the second talk is titled The Software Engineering Roadmap. And the third talk was unfortunately postponed or cancelled. So today we're more than honored and privileged to have here with us Dr. Nabil Hadj Ahmed. So he's a Google Cloud developer expert, a Google Cloud authorized trainer, and also a cloud lead architect. And that he will expand and enlighten our knowledge by his inspiring talk. So don't hesitate to ask your questions and drop them in the comment section. They will be taken into account and answered at the end of the talk. You can start, Dr. Nabil Hadj Ahmed. The floor is yours.
Can you see my screen?
Yes.
Okay, assalamu alaikum. Good evening, everyone. Welcome to DevFest22 Algiers, GT Algiers. First of all, thank you for inviting me for the event. And well done on a very well organized event. My name is Nabil. I'm a GDE Cloud based in the UAE. I'm also a trainer, authorized trainer, director of training with a company called Jellyfish. So today we're gonna talk a little bit about a tool in Google Cloud called BigQuery. I don't know if any of you guys have heard of BigQuery, but here the focus is going to be about big data. So big data is always challenging to analyze big data, to get information, get insights from big data. Usually there's a couple of issues about analyzing data at scale. Is either it's going to be compute capabilities that usually we struggle with. We don't have enough money to invest in order to deal with a huge amount of data, and other challenges like the skills not there in order to do and deal with big data, and many other challenges that we're gonna be talking about, and we will see how BigQuery came about to deal with those challenges and give us like capabilities more than dealing with analytics. So we will talk about machine learning capabilities with BigQuery as well. So just a little bit of a background about BigQuery. We'll have an introduction in there, and then we'll take you through those challenges, and we'll have a couple of demos in this session as well. So what is BigQuery? BigQuery is a data warehouse solution in the cloud. So usually when you are on premises, you are on your own computer room, data center, there's a lot of challenges. You struggle to answer many of the analytics questions. So first of all, when we're dealing with capacity, capabilities of compute, storage, and memory, difficulty to scale, performance challenges, and then you will always be looking at doing capacity planning, looking at ahead of time, needing to upgrade the hardware accordingly. We know that hardware have got life cycle, so you will find yourself in every 2-3 years in a situation where you will be upgrading hardware. Not only that, you will be looking at licensing one of those major upfront investment any company will have to do, will have to review all the time. You miss renewing licenses, you'll be paying a lot of money for breaching contracts with vendors. And also when it comes to data warehouses, he's always will be looking at batch processing. So you'll bring an amount of data once a week, once a day, once a month. And then you collect that data from multiple locations on a regular basis. And And then what's lacking in there is streaming. So data that is coming in real time. One of the other challenges that we will find in on-premises data warehouses struggle with. They're not designed for real-time processing. And also, when it comes to machine learning, data warehouses never been an idea of having to think a little bit out of the box and think, okay, I need my data warehouse also to do machine learning. That's never been the case. So when you're dealing with data at scale and you're looking at machine learning projects, AI, you will be looking at tools to help you prepare the data, and then you will be looking at data and taking it somewhere else to a different platform where you will be doing machine learning with coding. You need the right capabilities when it comes to compute and storage, but the data warehouse or data analytics tool will not going to be help you with machine learning. And then also, because you will be collecting data from many sources, you will be having governance of who has access to your data from multiple locations. Security governance, always a challenge, always issues in them. And also the ongoing maintenance, the ongoing operational model when you have a data warehouse on premises, there's also a challenge in there. There's a lot of complexities around that as well. So BigQuery came to solve those kind of challenges. So we're going to talk about scaling. How does BigQuery scale according to the demand that we have, according to our data that we have here? So usually, like I said earlier, when we talk about your own data center, and you will be looking ahead maybe at the beginning of the year, what kind of data analytics project you will be looking at over the next 12 months. And you will be basically estimating how much will be data you will be looking at, how much analytics you're going to be doing that. And based on that, you will be basically investing into that hardware. You will be saying, okay, I need this cluster of servers, this much CPU and memory that I'm going to need. But what you will find most often is that estimation that you've done and the jobs that you're going to be running, they will never be in par, which means that sometimes you will be having those jobs to do data analytics on that will need more compute. So you might be having, to do multiple jobs at the same time. So the capacity is not going to be geared towards running complex analytics in parallel. So you will find your jobs are queuing up. So you will have to wait for one job to wait for another to finish. And in that situation, you will be basically losing time. And in other situations where there is no big demand, you will be basically losing resources. So those resources that you did a lot of investment up front, they are sitting there idle, doing nothing. So you will find yourself in those situations that sometimes you are what we call over provisioning. So you're not using your resources that you invested into their full capacity. And in other situations, you will find yourself that you are basically under provisioning. The jobs that you are there waiting, queuing up to be completed, to be executed, you are losing time. So you are either in a situation losing time or in a situations where you're losing money. So in the cloud, when you use a tool like BigQuery, and we will see how that is possible, whenever you need the job to be run, BigQuery give you just the right resources in order to run that job. And then when it comes to licensing, renewal costs, and all that stuff, because it's going to be like a managed service in the cloud that Google will take care of for you, you don't have to worry about those things. So it's a pay-as-you-go model. So you will be paying, for the analytics that you're going to be doing. The rest of the infrastructure is completely looked after by the provider. In our case is Google in our case. So there's no licensing to pay. There is no renewal for hardware. There's no contracts to renew and things like that. And also those kind of limitation when we talk about on-premises for streaming, now BigQuery will come to solve that. BigQuery's got capability to stream data, which means if I've got sensor data, I've got sensors, I've got IoT devices that I'm collecting data on, I don't have to worry about does BigQuery have issues with that. BigQuery will have a streaming layer that deals with data that is coming from multiple locations in real time. So you will be able to do near real-time analysis of your data at scale. And we will see also that BigQuery got capabilities of machine learning. And this is where we will bring in the point here that what Google are trying to do is democratize machine learning and data analytics at scale, just running SQL. So if you know how to write SQL statements in the SQL construct, then you will be basically able to do data analytics and machine learning at scale. And we're going to see that BigQuery has got a layer on top of the analytics engine that will help you and make running machine learning algorithms just by running SQL. And then when it comes to security, governance, maintenance, and those operational complexities, in that case, they are all gone, because the infrastructure where Google BigQuery is running, it's not for you to optimize. It's not for you to think how to upgrade or patch and things like that. That's all those kind of what we call these days thankless jobs are done for you by Google. So the idea here is to let data engineers, machine learning practitioners, data analysts, let them focus on the data, let them spend all their energy and time in order to add value to their business by adding more, getting more insights from that data, adding more kind of predictive power to their data to make their business more competitive and add value to them. And it's been running like BigQuery compared to how is it in the market is you can see here for third year running, I think it's been there, from the competition, from other products that they do like machine learning, data analytics at scale. BigQuery, it's a market leader pretty much. And this is what we call the skeleton architecture when it comes to data analytics. So you will have, let me just get my laser pointer here. So you'll be collecting data from multiple data sources, and here we want to see the capabilities and kind of the ability of BigQuery to be able to collect data from multiple many data sources. It doesn't have to be a Google product where you'll be able to bring that data in. It can be sitting anywhere from third-party products, from different cloud providers, from on-premises. And then you can collect that data through many tools. So there's connectors, there is all the services in GCP that help you to bring that data to BigQuery. You can even do a direct import to BigQuery with a BigQuery service. And then you will be able to, there are other tools in this data analytics pipeline in GCP that are completely serverless, they are completely fully managed for you to prepare the data, to cleanse the data, to do those complex, management and preparation of data before you can use here BigQuery as a storage for a data warehouse. But also what you will see here, data BigQuery is in many places in the skeleton data analytics pipeline, where here we're using it as to import the data, and here we're using it to store our data, whereas here we're using it to do analysis, to do the analytics that we are after here in the analysis phase. And then from there you can export your data, you can visualize it with external tools to get dashboard, do business intelligence, to help you make those business decisions based on complex use cases. And just hinting here at BigQuery being two services. One is storage and one is the analytics. That's going to help you to the analytics. So we're gonna talk about the architecture of BigQuery being two services in a moment. And when we talk about the storage, again, the first service that is part of the BigQuery tool is the storage, and how is it done? So BigQuery is, when we talk about BigQuery, how data it is as a data warehouse, we have what we call data sets. A data set is equivalent to a container for many tables. So, and it is stored, the data is stored into what we call columns. So the storage is optimized in a way that a column in a table is stored in a file on its own. Okay, usually databases, they are the database records, they are how they stored on the storage, they are record based. So you will find multiple records from your database stored in one file as a chunk, as one. So when you query the data, you will be getting all those records in one chunk and then basically getting the data from there. In BigQuery, because it's stored in columns, so when you are trying to query your data, the data is going to get back from the storage as just the files that you are wanting, just the columns that you want from your query and the analytics that you want to do. And that's why it makes it fast, it makes it cheaper, and it makes it very, very efficient. Instead of getting all the records and all the columns from those records, you're just getting just the records from the table that you want when you run the queries. And each table is compressed, and is encrypted. So not just in BigQuery, so in Google Cloud, all the data is encrypted at rest. And Google, they give you the option if you want Google to manage the encryption keys for you, or you can manage the encryption keys, or you can bring even your encryption keys. But nothing is allowed to be running encrypted. No data is stored in any Google Cloud storage, any of the database services, encrypted. So everything is encrypted, and BigQuery is no different. The storage is durable. Each table is replicated across data centers. So here, the zones, we call them a region. You can think of a region as a geographical location in the globe. So it could be a city, like we have now multiple regions. We have, I think, 35 or 36 regions. So 36 cities across the globe distributed through North America, South America, Europe, a lot in Europe. We have in the Middle East, Australia, the APAC region, and recently Google, they are opening also in Africa, in South Africa, another region, and each region has got 3 data centers. So each of these tables, they're going to be replicated through these data centers. So if something happens to one data center, your data is basically durable. We'll be able to get to that data, which is for resiliency, high availability, and disaster recovery. This is super, super useful. And like I said, it does support streaming, so we can stream data directly to BigQuery. So BigQuery Storage API, treat data warehouse storage like a storage. So we are saying here, BigQuery is 2 services. So the storage that we talked about just now, that is columnar-based storage here. So, and then we have an analytics, or we have a query engine, which is kind of the compute capabilities of BigQuery that does the processing for us. And basically the call to BigQuery, we're just going to make an API call. So if I am going to run a query, I'm just going to make an API call to BigQuery engine and run my query. That's going to get my data from that storage. That is really, really efficient and very, very fast. So, and I can connect to different other tools and technologies. So I can, connect to BigQuery to Hadoop or Spark. I can connect to Dataflow, which is another tool in GCP that does batch and streaming, ETL pipelines, extract, transform, and load. So BigQuery is really good at doing transformation and preparing data, but it uses SQL language. So for those complex use cases where I've got a complex transformation that I need to do, there are other tools. That Dataflow is one of them, that uses Apache Beam. So it's pretty much Python and Java coding in order to do data processing. And I can use connectors, ODBC, JDBC, to third-party tools as well. And there's loads of those custom connectors that basically allow me. So if I go to the Google Cloud Console and I don't find something specific to my data, I can create custom connectors to get my data to BigQuery as well. And when it comes to loading data to BigQuery, so we've got many tools here. I can do batch ingestion, so which means I can bring my data, like I said earlier. This is what you expect from a data warehouse, to do batch data. So you bring data in bulk. So the idea of data warehouse is to have a huge amount of data, petabytes, billions of records, millions of records, and you bring that data in batches. So you might have like your own databases that are, updated on a daily basis. The data warehouse, usually you update, you bring the last 3 months or 6 months or 1 year of data. You want to do some analysis, so to find out trends and things like that. This usually happen on a huge amount of data. For historical data, you bring to data warehouse. So you do it in batch. But also, like I said, streaming is another feature of BigQuery. So I can bring data in real time, and I can query it also in real time. So there is a buffer that helped me to query that. So it doesn't have to wait to be written to the storage, because that could take time. That could be a bottleneck for being able to analyze data in real time. So there is a buffer layer where the data, streaming data, is going to be there, and I can ingest gigabytes of data in seconds. And I can use, to materialize my data. So I can use queries, I can use federated queries, on external data sources, and bring that data and materialize it into what we call, there is like a temporary or a cache, okay, and there is finalized tables, or materialized tables. So a lot of options here how to bring data in. And also Google, they've got their own data transfer service. So this is something that you can schedule. So if you want to do something on a regular basis, there is a service in with BigQuery that will help you to schedule on a regular basis, data to come from multiple locations. So you can automate the process through this service to do that ingestion and bring that data from different data sources as well. So again, from other sources, so it does support multiple data types: Avro, CSV, JSON, ORC, Parquet, and this will help you basically to break down those data silos. So usually data, what you will find, even within the same organization, you will find data that is sitting in multiple locations. You might have somebody having a computer under a desk where nobody's got access to that data. So here, with BigQuery being able to have like some sort of a mesh that I'm going to bring all that data and have governance, control, security over just one from a single kind of repository or single location. I can also do table joins, and I can also do federated queries. So table joins, those situations where you have data in multiple tables. So you might have brought a relational database, the tables that are in there, you didn't do just the transformation, you brought them as tables into BigQuery. So you can do joins because SQL. So whatever you can do with SQL, you'll be able to do with BigQuery. And also those situations where you want to query the data directly, you don't want to bring that data into the BigQuery storage and then do the queries, because those situations where, for example, you will be analyzing data that is changing so frequently. You might have like a spreadsheet, you might have like a database that is changing, let's say every minute, every 5 minutes. So the time you're going to bring your data, import it into BigQuery, and you're trying to do analysis and run some query on that data that you just imported, in the source, the data is already changed. So you will never get the latest kind of analysis on your data. So this is where we will query directly the data from its source. This is what we call federated queries. And BigQuery is one of the most popular tools in Google Cloud, and they have been it's been running for a long time, and they keep improving it. So here we have an example of a query that was run back in 2018 that was taking 1 minute 53 seconds something, and now it's running in 4.2 seconds. So they keep improving the service. as we every year, and improving the technology, the research on it, and so on and so forth. Before I talk about the BI engine here, which is another layer on top of the BigQuery, and this is just to help you to being more efficient, having to run data analysis in real time. Okay, so BigQuery, they put on top of that a very fast cache on the top of the storage they have. That will allow you to have a real-time analysis of your data. So this cache, the storage layer of the cache, is super fast compared to the storage that we have. And basically, this will help you with those situations where you are streaming for real-time data that needs to refresh in real time. So the BI engine is sub-second queries, whereas the normal BigQuery, like we're going to see, I'm going to take a couple of examples in here. But usually, if you have big data, we're looking at seconds in some instances, minutes in some instances, depending on the size of the data, the complexity of the query. When it comes to workload management, okay, so BigQuery is reliable. So we have this 4 nines uptime SLA integrated. When we talk about governance of data, protecting private data as well. So there is tools in GCP that help you with that. If you want to have the lineage of your data, for example, what happened to my data before came into BigQuery, what kind of transformation happened to it, and what is the next step in my data pipeline, in my analytics pipeline that's going to happen to my data, where is it going? So this is like, we have a data catalog tool in there. Cloud IAM is for security. Who do you want to give access to your data? Who should be running queries? Who should be connecting to external data sources? And the Cloud DLP, this is another tool in GCP that will basically protect your personal identifiable information, PII. So, when you are doing analytics at scale, you have private data for your customers, where, for example, their email addresses, for example, their social security numbers, their credit cards. So the DLP will help you to obfuscate that particular data from to be displayed to people who shouldn't be seeing that data, that private data. And when it comes to encryption, obviously it's encrypted, replication across regions. We've got other controls from security perspective to help you with data exfiltration. So those use cases where you are worried about, you get somebody working on your data, or a hacker hacking into your, perimeter on your project, and you want to block him from copying data outside your project that you are working on. And also compliance. BigQuery's got compliances for many industries, like the finance industry, the healthcare. So there is no issues there as well. And when it comes to pricing, okay, is it pay as you go or a fixed monthly subscription that you want to do? But here, you're not basically doing any upfront investment. You're not investing into a hardware or anything. It's basically a pay-as-you-go model. So you're moving from what we call a CapEx, capital expenditure model, into an operational model. So you pay for the operations that you run on BigQuery. So from access control perspective, this is what we call the resource hierarchy in GCP, in Google Cloud. So you have your organization node, you have multiple projects, and you have your data sets in BigQuery. And then you can give external users, internal users, access to your data. So there's many mechanisms in order to have granular access or granular control to my data in Google Cloud. Now, the data sets, what's in the data sets? Like I said, you have tables, you have, now with BigQuery, you can even give access to some columns, you can have access to rows as well. So you have granular level to that level, data set, table, columns, rows, so you can control the access to the very low level of your data in BigQuery. And here is another other capabilities of BigQuery. So being able to analyze data, not just sitting on Google Cloud, but all in other cloud providers or on premises. So we have a product based to be able to run analytics on data sitting, not just in GCP, but on, let's say, AWS or Azure. And this is what BigQuery Omni will help you. So again, we're not breaking those silos from within our organization only, data sitting in Google Cloud on premises, but here we are just extending the capabilities in there, being able to do data analytics on like a multi-cloud environment as well. So you can link your data to BigQuery to be able to do those kind of analytics on a multi-cloud environment as well. And again, it's completely fully managed, so we're not having to worry about how is it going to work under the hoods, who's going to be managing that infrastructure, who's going to be scaling it for us, and so on and so forth. And before I talk about BigQuery ML, so how come BigQuery is efficient? So let me just do a couple of, or the demo here about BigQuery. And then I'll talk through why is it efficient, and why is it a leader in the market when it comes to data analytics tools. So let me just share here again. I'm going to share my console. Share screen. Okay. Please let me know. Can you see my console there? So this is the Google Cloud Console. So if we want to get to BigQuery, it is so this is the BigQuery window. So I'll have this UI. This is where I'm going to be running my queries. This is my data sets in here under my project, and you can see here I've got different tables. So I've got tables underneath that. You can see the details of my tables. So multiple different data sets here. I can see the details, how many rows, what is the size. I can do a preview in here. Okay. So let me refresh here, or I can see another table here. Maybe. Okay. Empty tables. So anyhow, this is the my data sets here, and underneath that there is tables. I can open them, I can share them, under the data set I can create tables, can delete. But let me just give you an example of a query here. Maybe make my screen a little bit bigger here, maybe. Okay. So here's an example of a query. Let me make this maybe bigger here. And I'm looking at a public data set, a Wikipedia benchmark, and I'm looking to get some kind of select of the language title. So if I look at this table here, and you look at the schema. So I'm looking at the language, I'm looking at the title, and I'm doing a filtering around title, like anybody who looked for the title contains the word Google, okay? And what language was the title in? So I'm picking up, I'm doing a grouping around that. And if I look at the details of the table that I'm looking at, he's got here around 125 million records. The size of table is 8 gigabytes. So it's not huge, but let's see, try to understand how BigQuery will process that query here. So these are my results. You can see here how many times the word Google will appear with the different languages. And if I look at the execution details, it completed that in 1 second. And we have another time consumed here called slot time. I'm going to talk about slot time in a minute. But let me just get a bigger, more data we can analyze. So this one here, for example, let me just get something more significant than that. Trying to recognize these queries, just. Okay, so let me scale this one to from 100 million. I'm gonna go to 10 billion, and I'm gonna look at the difference in. So 100 million to 10 billion, pretty much we are scaling to 100 times pretty much in here. And we will see that the previous one will take 1 second. I'm gonna see if that's gonna take 100 seconds or less. So again, if I look at the execution details, and it was only 5 seconds. And what you notice here is that slot time, 1 hour, 6 minutes. So what is actually the slot time? So like I explained earlier, briefly, BigQuery is 2 services. We have a storage that these tables are stored, each column in its own file. So when I do a select, this select statement, language, title, sum of views, I'm just getting 3 files in order to run those queries. And then I've got what we call a cluster of compute units in order to do that processing. So what we're doing here, Google, what they've done, they decoupled the compute from the storage. Usually when you have servers, you have CPU memory and a disk with it, storage with it. So here, if you have a cluster of those, many of those servers where you have the storage and compute together on the same server, if you want to scale, it's going to be difficult because data will be sharded into multiple servers. You will have to shut down. You will have to basically distribute data across all those servers. So Google, what they've done, they completely decoupled that, which allows them to give more compute without, worrying about, I need to take that data and divide it and shard it into multiple VMs because it's completely separate. I don't have to worry about that. So I can give more compute to that data that is in my storage without having to reconfiguring the cluster of these compute units and the rest of it. And that's what allows you to do, to be very, very elastic. So one query that needs, let's say, 100 or 200 compute units, because the query is complex, the data is too big, then you don't have to worry about that. Just give it the compute and bring the data to that compute to do that processing. Now you might be thinking, it might be slow. Well, Google, they worked many years on the network between the storage and compute and made it super fast. You don't even notice any latency. You won't even think that the data is not stored with the compute. So it's like 1.3 petabit by section per second by section network. So super fast network in there. So here, what we are saying here, the slot time, slot is basically the compute unit from that cluster. So here, what we're saying, if we run this query on one slot, it would have taken 1 hour, 6 minutes. So if we want to know how many slots BigQuery has given us for this query, we divide 1 hour, 6 minutes by 5 seconds, and you can see a huge amount of slots given to that query. So this will allow you to do, you no longer have that situation where you have on premises, you are waiting for resources or you are over provisioning. So here for each job, BigQuery's got the intelligence to analyze the complexity of the query. It will look at how much storage, how much data you're analyzing, and it will give you the right amount of slots to do the analysis in the most efficient, the fastest possible way. So I can even scale this to 100 billion records. So I've got a data set with 100 billion records. So if we look at this data set here, and just to show you here, so now the table itself, let me just go back here. So if I look at this, this is the 100 million. So we're looking at, yes, now this one. If you look here, we're looking at 105 billion records in here. The table on its own, the table size is 6.76 terabytes. Okay, so if I want to run this query, now BigQuery is going to look at this. He knows what's the size of these files for these 3 columns, and it's going to give you the right amount of slots in order to run that. So if I run this query, let's see how long that's going to be taken for this 100 billion records or 106 billion records. And now it's going to give me another configuration of that cluster with a different number of slots. So, the other one took, I don't know how long, 5 seconds, but this one we're talking 100 billion records. So it's a scary number. And it came back in quite fast time, 23 seconds, okay? So if we were to run this on one slot, it would have taken 12 hours, 32 minutes in order to run this query, okay? So this is the amount of time you would expect to, on premises, if you have one massive big server, you would be waiting for this query to run for 12.5 hours. Or if I was to run it on one compute unit this is what it would have taken. And in here, you can see, because it's so easy now to explore, I can create a dashboard from here to do my, let me just show you that. So I'm clicking on that, it's going to go and create just going to share the other window with you. Share screen. So it goes and just a click of the button, it's just going to create for you a dashboard for those results. Obviously, here we're looking at 100 billion record query. To visualize here is going to take a bit of a few seconds. We're not talking here minutes or hours. There you go. So I've got because visualization makes those business decisions, if you want to make from a visualization, easier to make rather than looking at table with numbers and things. So here is going to come up and show me, which is the most searched title with the word Google, and which language is the highest number dashboard. Okay, I can start seeing them. There you go. So you can see here. Am I sharing my the dashboard? Is it appearing on the screen? Yes, there you go. Yeah, so you can see here now we have English, the Google word in those titles are 6 million something, but you can see here this dashboard. I didn't have to configure that. So, you know, we have Looker Studio directly connected to BigQuery in order to give me that visualization. I didn't have even need to choose which columns I need to get. So BigQuery will figure out, okay, based on the grouping, on the analysis you want to do, it gives you the dashboard in order to answer those questions from just a visual like that. So that's in a nutshell about the capabilities of just using SQL. So and there is another feature beyond the BigQuery Omni that we talked about. Now Google they having this on another layer on BigQuery using natural language processing, which is called data Q&A. So with the data Q&A, you don't even have to write any SQL. So you will be asking questions in the natural language in English. So let's say I want this query, you will be asking the question, you know, what is the most, you know, searchable, or how many kind of, or what is the top 10 titles in what language they've been doing that. Okay. So and just a couple of minutes on the machine learning capabilities. So let me just show you that. And from machine learning again, you can run machine learning with simple SQL statements. Sorry, time is pressing here. So let me just. So also with the simple SQL statements here, we know how challenging can be machine learning with, especially if you are a data analyst, data engineer, you rely on machine learning engineers with a lot of kind of expertise. So here we have what we call BigQuery ML, and with BigQuery ML, you will be running machine learning algorithms in a simple SQL statement. So you will be creating a model, specifying what kind of model you're having, and basically you will be serving you specific data that you are running. And like here, for example, you have your data that you already prepared. You create a model with a SQL statement. So there's no Python, there is no any other languages that you would expect for machine learning. You just specify the data, specify what machine learning algorithm you want to run. Is it logistic regression? Is it any other model? That we have loads of models that we can run with just a creator, and then you evaluate it, and then from there you predict and you give your users access to results, and they're completely customizable. They are default customizable for advanced users, and this is a set of models that you can run: classification, regression. You can import from TensorFlow, you can export to TensorFlow, so on and so forth. And this is what we're talking about here. Democratizing in here, using BigQuery ML, visualizing with Looker Studio or Looker your results in there. And with that, thank you for your attention in here. Thank you for your patience. Hope you learned something here. Thank you for inviting me. If there is any questions, maybe you can have a couple of minutes here. Otherwise, I would see you in the future sessions in the future. Thank you.
So thank you so much, sir, for this outstanding talk. It really was amazing. So now, if you don't mind, we'll be moving to the Q&A section. So the first question says, what Algeria has to offer as infrastructure to make a cloud provider like Google think to install one of its data centers here in Algeria?
Wow. Oh, this is an amazing question. I think, yeah, I think this goes beyond my, but really good question. You know, I've been asking this question for maybe 3 years now to try to because if you look at the cloud marketing at the moment in Africa, there is nothing from Google. There is maybe a couple for AWS and Azure. So the first country, especially in the north, who's going to get like a region in infrastructure for that cloud provider, it's going to make a huge difference economically to the country, to the skills of the you guys, students who come up from the university and things. So I think this is a level of kind of political decision from the up in the level in the that they need to make that call. But yes, if we it would be great if Algeria is going to be one of those regions of Google Cloud. Is makes a huge difference to the economy of the country for sure.
Yes, thank you so much. And Ashraf is asking you to share the files with us, if it's possible.
Yeah, of course. I can share them with the team, and they will be able to share them with you. Yeah, for sure.
Yes,
No
we'll be
problem.
sharing them in the community server.
Yeah.
Thank you
I'll
so much.
share them with you, and you can share with the guys. No problem.
And we have a third question that says, is the pricing plan different between storage engine and analytics engine?
Yes. So the pricing, like I said, the pricing for BigQuery, he's got two models. Now, if you are using BigQuery not very heavy, so it will charge you for each query that you run. It will analyze, how much data is being processed, and I think it's something like $5 per terabyte, and you get 5 terabytes a month for free. Now, if you are a heavy user, then you will be charged not per the amount of data that is processed, but the number of slots. So you buy a number of slots, like 2,000. I think you can buy them in 500 or 200 bulks. So you buy a certain amount of slots, and then you can run as many queries as you like.
All right. All right, sir. So thank you so much for this talk. We're more than honored to have you here with us.
Thank you. It's been a pleasure. Thank you. It's been a privilege. Thank you for inviting me. Keep up the good work, and see you on another sessions in the future, hopefully.
Thank you so much. Thank you
Okay.
so much.
Take care. Bye-bye.
Take care.